Okay, hello. This is week 9's topic. It's about chatbots and how to create chatbots. What are chatbots and what are the problems with chatbot? It will slightly we slightly change the complexness of the problem, because before we was doing some not uh, systems that were containing only one problem, but chatbot is multi-complex problem, so it has many steps to do it, and there can be very very simple chatbots, and there can be also very complex chatbots where there are many algorithms, and there can be so different types of chatbots, and so, okay, let's go on. Conversational agents. Okay, let me zoom off. So, what is chatbots? For example, this can be phone-based personal assistants. We know the Siri, Alexa, Cortana, Google Assistant, where you speak something to it and it understands you and makes some things for you, make some searches and etc. So there can be different problems. Talking to your car, so you can also work with your car and your car will be doing some things. Communicating with robots, clinical uses for mental health, chatting for fun. So these things, they are same, but they differ on purposes and what you want to do and what you want the your bot to be to do. Two kind of conversational agents, chatbots and goal-based dialogue agents. Chatbots is something that is you are chatting with bot. Mostly it is like there is no goal. You can chat and, for example, for fun, you say something to chatbot and chatbot answers to you. The second thing is goal based. It's very narrow. So, for example, Siri, booking flights or restaurants, they are simpler than chatbots. Why? Because they have actually the person, human, will not talk about anything that the goal. So, for example, if you are making booking flights or restaurants, you cannot ask about movies, and your chatbot should not know anything about movies. So, or same for Siri, it cannot know anything that is not related to phone or internet. So it can search for your internet or make something in the phone. Of course, they can add some features like in chatbots. They can talk with you and they can like make a fun with you. Uh, so again, this term is used for different things. So for example, this can also be referred to this part. So they are also conversation between human travel agent and human client. So there is some speech. I need to travel in May, and when, what day. So this is human client and agent, and what day in May did you want to travel. So here we see the thing that it's saying some words and chatbot understands. Okay, it want to specify which day, and then it says therefore meeting that's room for 12 to 15, and then it says, for example, and you are flying into what city. So it's again this client agent, it want to fill some information too. So this information is not enough to take a flight, but each time agent it asking for several features about what it want. Properties of human conversation. So there will be some part about like theoretical part of how people's conversate with each other. So first one is turns. So each time, like in older razzia, in for police, you know that they do not speak like in two ways. They speak in one way. So when someone says and second is stopping it and says back, and only one in turn take when you to take the floor, when to yield the floor. Again. Okay, let's so we will pass this one. So it's actually about how what people do and how we can specify it. Constatives. So you answer something or claim or confirming. So you and directives. For example, directives is do something like this. Commissives. Asking, betting, vowing, betting, opposing, etc. Acknowledgements, and you give a knowledge. So this is like different types of classes of a speech. So maybe defining these classes will help you to classify that type of word. Okay, let's pass this grounding. So grounding is making sure that two people are saying about two things, same thing, not different things. So for example, this one, okay, I will take a 5-ish flight on the night before of the 18th 11th. On the 11th, okay, so you see that it's like asking if the agent understood the words. So this is called grounding. Grounding is important for computers too. Did you want to review some more of your profile? No. What's next? So for example, in this case, okay, what is next? You are so in this case the caller will not understand if computer understood or not, or got this message or not. But for example, in this case, okay, what's next? The caller will understand that this is like so the message is it considers the things, for example, this word no and the next question. So when you say like something what's next, you do not give some information about confirmation that you received this message. Maybe it was lost or something like this. Conversations have structures. So also you can divide conversation into some structure. So some like there is also always question and answer structure, proposal, acceptance and rejection. So if you say, do you want to buy this ticket, the people must say yes or no. So if there is no such structure, it may lose some points. Another kind of structure, sub-dialogues. So sub-dialogues is like dialogues that so we have main dialogue, and inside the dialogue we have sub-dialogues, which is like some extra things like so for example like this, there is some chat about buying a ticket, and the client asks what day of the week is the 15th, and it says it's Friday. So also you see that it asks question which is not related to buying a ticket, related but not directly. So but this agent should also answer these questions. Clarification sub-dialogues, what they have going to unknown word on the 5th. So for example, this word was person said it unclearly, and the system asks what did you actually said here, and it respond and to clarify the thing. Pre-sequences. Okay, conversation initiative. So also this can be initiative who co-initiate the speech. So for example, sometimes you can make user initiative and system initiative. User initiative so for example, this one, you say I want to buy a ticket for this city for this thing. In system initiative, you say you enter, and the system starts ask questions like here you can say please buy me a ticket for Boston to Washington, and if it will find or not, and the system will try to find the slots. But in system initiative it will say you cannot write in clear form. Maybe you can, like, it will say, okay, please write the city, please write the city of where you arrive, and etc. Inference. So for example, here the system should understand, this agent should understand that how to buy these tickets if meeting is from 12th to 15th, because should be from 11th to 16th, or should be to 12th to 15th, and maybe some qualifications. Properties of human conversations. Okay, chatbots. So the very all these examples of chatbots, it's also like many things in artificial intelligence have very old history, and from the beginning of people created their computers, they tried to do something like they tried to imitate humans, and the many things that were done that days, they were like today's artificial intelligence. So for example, Elisa and Perry, this system was first to pass the Turing test, Blender board, XLC, etc. So chatbot architectures. What is chatbot? Pattern action rules, a mental rule-based, corpus-based. So we will see it later. So this is two types, rule-based. So in machine learning, many basic things, like all the things, they were rule-based. What does mean rule? It's like from programmer perspective, when you try to write rules and computer makes them. So today's and state-of-the-art machine learning artificial intelligence problems, they are corpus-based mostly. So they try to learn from the big amount of data and to answer the questions. Chatbots sometimes for fun, but originally designed for test bed of clinical therapy. So it's like if you have people which are mentally ill, so the chatbots maybe will help them to understand their problems and to like it's psychologists. Actually the psychologists, they also maybe some ask questions programmatically, so this thing is also trying to replace the person. Okay, so Elisa Weizenbaum, men are alike. So this is Eliza chatbot which are trying to answer the questions. So for example, this human says men are alike, and then this one says in what way they are always bugging us something or other. Can you think of a specific example, etc. So what does it do? It's actually looking like it's very intelligent. It's like the real person who answers, but it is actually chatbot which is written on rules. So there are some rules and it considers some rules. So actually it is dumb if you will consider today's chatbots, but you see that it's very good at it. The trick be a Rogerian psychologist. So Rogerian psychologist is doing something like this, reflecting patient statements. So reflect means that it, if user enters something, the chatbot returns its reflection. So for example, here it says, I want for a long boat ride. Tell me about bots. So actually you don't know what is bot, you don't know what is bot, right? But you can answer, understand that this is word bot, and you say tell me about bots. So for example, if it will say I want for a long bus ride, it will answer tell me about buses, and etc. So actually it's trying to trick you by some very simple things. So for example, there was some rules like this. Some word, you, me. So for example, do you love me or do you hate me? And Eliza answers in this form, what makes you think you? So you take this word, do you hate me, and put it here. So you hate me, what makes you think I hate you? So uh, you understand that this word is just put it here, but it's looking like really human-like. Eliza rules, keyword pattern. So there was many rules. Find the word in sentence that has highest keyword rank. If W exists, choose the highest ranked rule for V that matches sentence. So it searches for special words that is look like and applies some rules and then it returns. So there can be many rules and it like some patterns and you try to answer it. User, I know everybody laughed at me. I is a very general keyword. You say you know everybody laughed at you. So for example, this is I. Everybody loved you. You say so. You can answer in this way. So for example, you can write everybody transformation rules. Okay, so general word. So if they use some rules. So for example, everybody. It's more interesting, and you say who in particular are you thinking of. So there is some ranking between answers. So you can write something like this. You can do it like you say you know everybody laughed at you, and so it's waiting for the continuation. Or you can do who in particular are you thinking of. So for example, if someone writes everybody, you can do it in this way, and you can compare these two sentences and then make it like this. If it doesn't understand, it can say please go on, that's very interesting, I see. So to continue the speak memory, people ethical implementation. So there is also ethical problems. People became deeply emotionally involved with the program. So actually I think that this is the problem of that time, and people didn't know about the computers many things, but and they wants to, they think that is real, this real human like, it's not like rules, it's real person or something. One of the Weizenbaum staff asked him to leave the room, so they thought that they are talking to real person, and etc. So also there is some ethical issues. Anthropomorphism is like it making it it's real like human. Rule-based chatbots. Also the next step in chatbots was party, and is Eliza was something like this. It tried to answer you with regarding to your previous question, or something, and it only mimicked it. It find the ways how to answer, and Perry, which was developed in 1971 in Stanford, it was using some state. So the state was like this: anger, fear, mistrust. So it's like chatbot is doing like a real person. It may be anger, or it may be in fear, or mistrust. So people will develop it. Paris person, 28-year-old single man, post office clerk, no siblings and lives alone. So they give him some persona. What is he? What is his problem? And what he thinks. So they give him some personality. So in Eliza there was no personality, but here there is some personality, and it can give some information about himself to conversation to people whom he conversate. Mm. So he he has many different states. So regarding the state, he can answer differently. So for example, like excessive fear, excessive anger mentions delusions, question and answer. So he can answer differently. So sometimes he can show emotions. These emotions were written also by rules. So I didn't see it, but I think that it required many rules. Like, so they wrote these variables: fear, anger, and during the speech, during the talk, they changed these variables. So if the user is aggressive, it will answer aggressively, etc. So he will change his like this variable. So if you want to fear the parry, it will change its fear value, and next time it will answer you like with a fear, and sometimes anger and mistrust. Lots of complex IO rules, so I think it has many. So for example, this one, user mentions parry, say hey you parry. If it is positive, it decreases fear anger. If it is negative, it will increase fear anger, etc. So, so this is concepts. What to talk, how to play. Okay, what's your name? My name is Frank Speed. How old are you? What sort of work you do? I work in the post office. Why are you in the hospital? I shouldn't be there. Here, who brought you here? And so, for example, there he speaks about police. He starts be fearing, etc. So it's like Eliza saying, but they added one more structure. It's about their emotions. Corpus-based chatbots. So corpus-based chatbots, you collect the chatbot data. There will be millions of data, and you try to answer it. Human conversations mined in corpus-based chats. So you can mine these chats because in many times many companies they store the talking, and actually it's very important. There is a problem with doing a chatbot. Response by retrieval, using information retrieval to grab a response from some corpus. This is appropriate given the dialog context. Response by generation, use a language model or decoder, encoder decode to generate two architectures. The first is response by retrieval and response by generation. Retrieval, you get information from text. It's mainly done, we can say it as a programmatically by rules. So for example, if you it asks you some questions. Let me see. Turn training corpus of conversation, find C in turn that is most similar to. So the user asks questions, and you use this TF, IDF, cosine similarity and find the same questions, and then you find the most similar response, and they say this response. So actually it is very simple. You have many question answers, and then you find the most similar, and then try to answer. Response by retrieval, neural IR method. Okay, so also we can use BERT. I think we will discuss it in next 2 or 3 topics. BERT is special algorithm that changes the query text into some vector, as in word to vec, but in word to vec you can convert word into vector, and this in here in BERT you convert query into vector, and then you receive this word, this text, and also you've tried to find the similar words. It's actually quite looking quite intuitive. So you find the similar words, the similar text. Think of response processing is the decoder task. Generate each token RT of the response by conditioning on the encoding of the entire query and response so far. So for example, here you have encoder. Okay, so this one is recurrent neural network. There is a neural network which you give the variables, and then it produces some vector. Then it's sent to the decoder, and you try to enter the new word. So so actually this is like the query, the word they ask. What is the, for example, like here it will be when I can fly to Moscow. So for example, on 15th of February. Okay, so this is bad example because it depends on the day when you ask, but you can also add here some data. For example, you can add feature about when you ask this one. So it's a when I can find the Moscow, and you give also some feature which is date. Enter this and it trains, and then this is decoder. Decoder and it have answers, some answer. So it's like response by generation. The neural network and the system tries to so there is a pairs, like this is question and this is answer, and you when you enter this text, and it should answer with this one. So this the response by generation is like when you enter the text, and neural network the structure, some structure tries to predict this one, and you will have so the neural chatbots, they can be repetitive. So something like this, where are you going? I'm going to say see you later, see you later, see you later, see you later. So the neural networks, they because of their structure, they will be repetitive, and there are some things that makes it more easier to solve. Also, we can use IR to retrieve patches from Wikipedia. So hybrid architectures. So there are hybrid architectures where you use these two things, like response by generation and response by response production. So finding there are rule-based systems with neural networks. Chatbots fun, they are fun, good for narrow scriptable applications. Cons, they don't really understand. Rule-based chatbots are expensive and brittle. IR-based can only maintain the training data. Frame-based agents. So these chatbots is actually they can speak many different topics. Corpus-based chatbots. So what is corpus-based chatbots? So this is called task-based dialog agents. So it's mainly they are narrow. So they have some main topic like travel reservation or something like this, based on domain ontology. So the logic of this thing is about the chatbot dialog agent. It wants to learn something about its learn the main things, and it asks questions and try to find the question answer to its questions from the user's text. It's considered frames, the frame. So for example, a set frame considers is of slots. So for example, a set of slots. So for example, if you are buying ticket, it must have origin, destination, departure date, departing time, and airline. So it wants to fill the slots, and when it fills the slots, it understands that it can take this. Two basic architectures. The Goose architecture 4 years old. So for example, so the Goose frame-driven dialog system, it's still used. Dialog state architecture extension of Goose, more common in academics, still not valid. Okay. So this was written in 77. So it also can be used today. So slots can be complex, the type of date, and you also have to write this type of different forms, like it can write on Sunday, on this Sunday, on and many different things. Control structure, how it works. System asks question of a user filling any slots that user specifies. User might fill many slots at a time. So for example, there can be like the user system asks questions. You enter the chatbot and it says when you want to go, where you want to go, etc. Or user may enter this word. I want to fly from San Francisco to Denver one way, leaving after 5 p.m. So you can write like in name identity recognition to find the words like San Francisco, to specify Denver, and then for example you can write rules like find me word one way or two way, leaving after. So for example, you also may write rules leaving after 5 p.m. on Tuesday and something. When frame is filled, do database query. So when your program understands that this is the frame is filled, you find the all information it can understand, and for example it can confirm it and then go further. Gas system have multiple frames. So frames like different subtasks like car or hotel reservation, route information. So for example, you can fill different subtasks and it should detect the frame. So for example, if it says, first of all, you should detect the frame. So for example, which air flights fly from Boston to San Francisco. So you understand that this is like it want to take information and you should give some data. And so this is like ifs. First if it is about car or hotel, if it is about general route, etc. If, for example, if it's about car or hotel, you load some algorithm for car and hotel, which will ask for how many days you will stay, what you need, do you need TV or something like this, while general trade information, it needs information from which city to which city, and for example about airfare practices, etc. So this is like you first of all understand what is the frame, and then you fill the slots. Condition series goose architecture, active ontology, data structures a meeting has. So for example, you should specify what meeting have. So for example, if it is meeting, you should require an optional things, like for example a date and time, location, topic, listed and this. So you first of all should fill it, and then your algorithm will try to fill the things. Also rule sets very important, as we said earlier. These things like Monday at 2 p.m. you should convert it to this part. This also can be subtopic, which is you can use machine learning things, or you can use hard handwritten rules to do this. Collections of rules consisting of condition, action, etc. So this is like part of ontology of meeting task. Command, event, verb has a meeting, etc. Domain classification, asking whether booking a flight. So first of all, you should understand what user asks, what he want. Do he asking whether, and then you go to intent. Intent is also subtopic. Do he want find movie, show flight, remove calendar app, slot filling, extract the actual slots and fillers. So this is three main steps. First of all, you should understand domain. What is he talking about, user? What is his intent to find, to show, and so it also can be these things. All things can be written by hand, and some subtopics of this one can be written with some machine learning or also by rules. So each of these step can be different. So because of this, chatbots can be different in structure, in logic, and etc. Uh, Show me morning flights from Boston to South. So for example, in this case, you can also use like in RNN, or you remember name entity recognitions. We have some text and we must specify the top these parts. So here, for example, maybe we can do classic like this. We can send the text and then it should with neural network maybe try to predict this one by using this text. Natural language understanding for filling slots. Wake me tomorrow at 6. So for example, this understands by word wake, maybe. Yes, wake. Wake me. That it is about alarm clock. And intent set alarm. Also, for example, they are. And then time, it understands tomorrow word. And you should also maybe send the day, which day today. And the for example, this can be this can be tomorrow night, tomorrow's evening 6, but mostly people do not want this, so it will predict this part. How to fill slots. So for example, this one, rule based slot filling, you write the rules. You write that if he says wake me, set, get me up, you write these last rules, and then or you can do generate a template is a prebuilt templates can be fixed. Hello, how can I help you? Or have variables generating. So if you want to answer, you can write the rules, special words. So your text will be like same for all requests, but you can also improve it with these things like what time do you want to leave city origin, like or you can also make the predefined list of chats and you want to maybe answer it. Evaluating chatbots. So chatbots are evaluated by humans. This can be different. So for example, if your chatbot is very simple, like dialog agents, they answer the questions. So you can annotate it as say did chatbot answer correctly or not. But for example, if there is some complex topics, you will need many human annotations. There you can observe evaluation. Observer can say is chatbot is good or not. You can give what, for example, here they give eight dimensions of quality. So for example, if does it avoid abbreviation, does it make interestingness, making sense, fluency, listening, inquisitiveness, humanness, and engagingness. So okay. So dialog state architecture. So it is like Siri. Of course, in most today's you need some text speech recognition. You say it in by speech, not by text, and you generate these things. Living from downtown, living. So it tried to predict these words. Then you give your system gives it some probabilities like 0.6. This is one. This is most probable. Then it says that okay, we fill the slots from downtown, depart giant 1300, arrive time. You give the probabilities, and then you can ask questions and fill these slots. Also, it will generate different possibilities. And then dialog policy, you act, confirm, and then it says it generates speech, and then people can speak with it. Components in dialog state architecture. So dialog policy is about how to so for example, this one is also another topic, dialog acts, how to dialog. So this is can hello, inform, request alternations, etc. So it must take from words what is actually, which act is working. So it's like the structure of dialogue, and it makes the next moves to understand. So this is like structured thing. From this text, you should make it like this. So this is more like structured, and the computer will understand what to do. Slot filling, machine learning, okay, so this is slot filling is same as IO tagging, input output. Input, okay. So named entities, like named entities. So this is same, but named entities you have destination, departure date, and etc. Geo tagging for slotting. This is destination, beginning, I, continuing, and beginning, continuing. You can use BERT, which is good enough, which is when you send the text and it will give you this it's these variables, the task of dialog state tracking. So also you should remember the previous topics to ask in the question. So for example, you can also, there can be used keeper articulation, like if there is an error, the user can say it more loudly, and computer should understand that if someone uses says something loudly and slowly, then it is the important information, and so it should understand it. So for example, if the chatbot agent made an error, words like no, correction, I don't, should give that there is some utterance, there is not utterance, but some swear words also. If the user swearing, that it means that there need be some correction, etc. So okay, will not. So the natural language generation. Okay, I think that's enough for today, for this week's.